And we're live. Welcome to the 20th edition of the Decentralized Data Now call. I think it's the 20th. It's been a long time since we've joined each other, but I'm glad that we're back. Thank you to Gitcoin Grants for making this all possible. They have and Igor especially for being the largest donor to the Gitcoin Grants that's actually funding this video call. But with no further ado, we have a whole crew here. Let's pass the talking stick around and introduce each other. So I'll model. I'm Griff Green. I work with Giveth. Big fan of this decentralized data now movement. And I'm mostly just the comedian guy who gets to keep everybody engaged and entertained. I'll pass it to Dylan. And then Dylan, pass it to someone else after you're done, and we'll pass it to each other.
Okay, sounds good. I'm Dylan Miller. I'm the project lead on DFINITY Explorer. It's a community project creating an open source block explorer for the DFINITY network. And I'll pass it to Emil.
Hey guys, I'm with the Polkascan project, and we are building a multi-chain block explorer for the Polkadot universe and ecosystem. I'll pass it on to Jay.
Jay, your mic's muted.
Or Mark.
Hi, I'm Jay. Thanks, Emil. I'm working on a project called TrueBlocks, and I'm not building a blockchain explorer as I've explained before. I'm building an account explorer, which is an absolute minimal data gatherer. I leave all of the data on the chain and try to make the chain more accessible. And I'll pass it on to Mark. Yeah.
Hey guys, my name is Mark Patterson. I'm with the DataBlocks project, though we may be changing our name very soon. Well, we have to change our name pretty soon. We're working on a next generation, a hyperdata transport protocol. Some of you may be aware what hyperdata is if you've been around like the semantic web for a long time. It's been talked about in the context of the next generation of Web3, and now that's being spearheaded by blockchain. We're utilizing a next generation high performance data engine to connect data across in a universal data layer across every blockchain and even Web2 databases. So basically building the bridges between databases and data in Web2 and Web3. And I'll pass it to Victor.
Yes, I'm the last. Thank you. Hey guys, I'm Victor from POA Network. I'm working on, so I recently have been involved into the Block Scout project. My Block Scout project, so you know, it's an open source blockchain explorer for Ethereum-based chains written on Elixir. My responsibilities on the project is release management, bugs reporting, feature requesting, distribution tasks between team members, so and some DevOps stuff. And I'm here to share the major updates from Block Scout team for the past 2 months.
Well, Victor, you know, I want to start with you because really Block Scout is the hero of this group. You guys were able to create an open source block explorer, and really, I mean, with that creation, we even changed the name of the group. So if you want to start and give us your updates, I'd love to hear what's going on.
Yes, I will try to do this. So we have some exciting news about Block Scout project. The first of all, we have finished the full indexing of Ethereum mainnet Block Scout instance. Yeah, so we did it. Yes, a couple of words how we achieved this. At the middle of February in ETH Denver, we had 13 million of unindexed transactions, excluding simple token transfers and simple transfers. And moreover, we had a negative speed of indexing. So more transactions were coming that than indexer was able to process. And there was we changed in indexing scheme. So instead of using trace replay transaction API endpoint, we change it to use trace replay block transactions API endpoint. And it allowed us to decrease the number of requests to the archive node, and thus it allowed us to increase the speed of indexing. And at the end of March, we indexed fully indexed Ethereum mainnet Block Scout instance. So now all transactions are indexed, and so please let us know if any inaccuracies in token balances or any missing transactions. We will be happy to fix this. Yeah, so it was the first news. The second one, so we built Block Scout not only for the Ethereum mainnet, right? So we have support of other chains. You know, we support all of our POA chains, POA Core, so-called Testnet, and XDAI. Also, we have support of Ethereum Classic. Also, we support all Ethereum testnets like Robstenkoven, Rinkeby, Goerli. And recently, this week, we added support of some other chains, this iRoom, Callisto, and RSK. And we will continue this. So our strategy is horizontal scalability. Also we have there is a bunch of chains that we do not host, but as Block Scout an open source project, people took our code and built their own chains. They build their own instances of Block Scout instance for their chains. So, and also we plan to add some other chains in the future, in the near future. And the third major update is the cooperation with the EVM team in order to have decompiled smart contracts in Block Scout. So we have created a pilot integration on the smallest network to debug the integration. It was Goerli. Yes, we have created 2 JSON RPC endpoints, private one for uploading of decompiled smart contracts, and the public one to listing the contracts with ability to filter to get verified and unverified smart contracts, decompiled and undecompiled. And EVM team uploaded almost all decompiled code for smart contracts to our Goerli Block Scout instance. So everyone can check it right now. And we plan to add, repeat this procedure for Ethereum mainnet pretty soon. So this was major updates from Block Scout team. Thank you.
Nice. Well, I know that somebody has a question, but maybe I'll bring it to you a little bit later, and we'll just pass. Does anyone else here have any comments or questions to Victor? Okay.
I really love the decompiler stuff.
Is the decompiler Thomas's work? Did you guys integrate that?
Yeah. Thomas Kolinka,
Oh, very nice.
How's the quality of the data that you get from the decompiler? Is it that useful?
Pretty useful, yes, but it's rather a question for Thomas, I think.
Yeah, you spent a whole episode on that, right, Griff?
Yeah. When I can't remember what it was, but I think he uncovered something important for Ethereum that and the decompiler like found the bug. Maybe it was a Constantinople hard fork or something.
Yeah.
But yeah, that might have been the last episode, honestly. But yeah, I have a question from Daplion, who works with DAppNode for Block Scout, and so he's trying to work on the Dockerized configurations makefile, and he made it work as a Ganesh CLI instance, but it's indexing for like 20 minutes, and it seemed, and the instance is only 40 blocks. I assume he's running into some kind of issue there, right?
Yeah, I would suggest to move these questions to our Jitter chat or to GitHub issue or something like that, and our developers will try to find the solution.
So that's usually where you go. You just put a GitHub issue, and they get a pretty quick response.
Yes, right.
Excellent. Okay, well let's move. Keep this party moving, and I can't wait to hear about Polkascan and all the updates there. I'm sure you guys are moving at lightning speed.
Yeah, so I'll go next then. Everyone should be kind of aware that we're building the multi-chain explorer, and big news, we got a Web3 Foundation Wave 1 grant, and that allows us, you know, to really get the stuff going. And we've been really working very hard to get this show started. So in order to get to that multi-chain block explorer, we got this grant to build block explorers for individual substrate-based blockchains. So, and any blockchain that is built using substrate will be compatible with the Polkadot ecosystem and will be able to be included as a parachain in the Polkadot relay chain, creating that multi-chain system. So we got our first development update out last week. You can find it on medium.com/Polkascan. And basically, the grant comprises of 4 distinct milestones, which, you know, pushes the project forward. We're starting with the architecture, then we include the decomponents that all these individual blockchains built on substrate would have in common, and then we go into the details that differentiate all these individual blockchains from each other. And then in our fourth phase, we'll do some optimization and performance optimizations. Well, if you start building block explorers, you get into all sorts of performance issues, that the block time is a real hard constraint, that you need to do all your decoding and everything you need to do for a block, and the aggregation stuff within that block time. So that is quite a challenge. We are confident we can do that. We did build the EVM Explorer, and we did make it work for Ethereum mainnet, and crunching through you know, the Shanghai attacks and stuff that really well, put you on the spot to get that stuff sorted. So within each and every of these 4 milestones, we are building about 6 software artifacts. The harvester, a number of Python libraries we use in order to make that harvester work. We are building individual substrate clients to run individual nodes for these distinct blockchains. We are building an API that actually disseminates all the information that we harvest. And we are building a UI, a GUI, which is an Angular single-page application that actually displays all the data you get from the API. And we all combine that with Docker Compose files. So you can build Docker containers for each and every individual of our artifacts, but also you can use one single Docker Compose up command to get an individual block explorer for a supported chain up and running. So currently, you know, there are no real life networks in the Polkadot ecosystem. Everything is a testnet at this point. And that will stay at least for another month or 2. Then the first production nets will emerge, which is probably the Edgeware network. That's the Polkadot parachain smart contract platform that Commonwealth is working on. Yeah, and we currently support 4 testnets. The Alexander network, which is the testnet for the Polkadot relay chain. We support the testnet for Edgeware. We support the testnet for Robonomics, which is by Ira Labs. They're also active in the Ethereum ecosystem. And we support, as of today, the Joystream network. So next week, there's an event in Berlin. It's called Sub-Zero Summit. Sub-Zero Summit is an event which gathers all the substrate implementers, every organization building on substrate, and there we will present how to do that one-click setup with Docker Compose for our supported networks. And I'm very happy to come on board next time again to do a live demo on this channel as well. So
that'll be super cool. That'll be really cool. I'm curious. Is anyone? I'm surprised no one's building anything live on Substrate yet. Is there? What's the limitation? I mean, they don't need Polkadot to make a Substrate, right?
No, but Substrate, if it is not yet out of beta. You know, Parity Technologies is doing the finishing touch on most of the basic stuff to get that up and running. It should be done any day now. Then probably there will be API stability. There will be a big announcement, and that is actually what I know Commonwealth, amongst others, is waiting for. And you know, their launch is planned for end of June or July, I think. So it's just not ready.
Very cool. Does anyone else have any questions for Emil?
Yeah, I do. Emil, so is your harvester your indexer for all these different chains? Is that what the harvester is?
Sorry, could you repeat that, please?
How are you indexing all the different chains, the multi-chain explorer? Like, what are you using to index the chains and bring the data together and put it behind your API to offer that to people to access?
Yeah, so Substrate, which is the development framework that is used to build all these Polkadot chains in the Polkadot ecosystem, it is very generalized. So you can build any blockchain with that, basically. That's what, well, they tell us, and it's actually true. What we built is we have a Python harvester, a Python built harvester, which has a Celery heartbeat worker architecture. So it's really parallelizable. So what's the word there? You can, divide your tasks and with more Docker containers, we can get more performance. But our whole architecture for that multi-chain explorer is basically that we will run one harvester per blockchain. So the constraint is basically if we can harvest one blockchain within the block time, we can have multiple instances of that, and we can harvest as long as we scale up our hardware and our instances of the harvester. We can index 100 or 1,000 blockchains. Then, of course, you get into all sorts of service management issues, which is a challenge in itself. So we are building all sorts of, orchestration services to manage all these harvesters that are in existence. So on one end, we have the open source block explorer and the open source harvester that anyone can run by themselves if they want to have it for their individual blockchain. But as soon as you go to that multi-chain explorer, it really gets into service management and orchestration. And that is the real challenge to, keep track of everything you have running. And I guess that is where we want to go with our Polkascan.io platform, that we are going to be well equipped to pick that up and to service that.
Can I ask a question? Do you think that I'm asking for my own education? I really don't know the answer. Do you think people will be interacting with tens of different Polkadot chains, or just usually one chain or 3 chains, or just a general user? What's the expectation?
Yeah, so no one really knows, but I like an analogy I heard a while back. So I think what is a distinction between sharded Ethereum and a Polkadot ecosystem is the heterogeneity. You must have heard that. So a sharded Ethereum has many instances of EVMs, and with Polkadot you have a relay chain, which is the analogy of the beacon chain, and you have all these fit-for-purpose parachains, which are optimized to serve a particular purpose. They could be very generalized, an EVM or a smart contract platform, or a single or dual-purpose optimized function. So I like that diversity and that specialization in this ecosystem, because I guess the work will go where it fits best. And you could compare it basically to an economy, I guess, with individual companies. There's always specialization and generalization, and the work will go where it's cheapest. So I think it would go in that way, and whether that's 1 or 2 or 10, it depends on what you want to have done in that ecosystem, I guess.
Right. So a regular user might use many chains, many different chains.
Yeah, well, I guess you might need some stuff with identity, which is on an identity chain. You need something with a stable bank coin, for example, which is on a bank coin parachain. You may need something done on multiple smart contract platforms, so that's included. You may need some governance stuff, which would go to an Aragon chain or something like that. I don't know.
Yeah,
for sure, all be abstracted away in the end. Like,
yeah.
Early on, it's going to be a bit messy, but that'll eventually get abstracted, and it'll just be super intuitive, like the internet is right now. But
yeah, and I think there's also this optimization that all the interchain communication will probably be more expensive than the stuff that happens within a chain. So it's really interesting to see how this develops, and I think it will need a few years for anyone to really be able to give an answer to that sort of stuff.
Yeah, we got to keep going because there's too much to talk about. We haven't talked for like 2 months or more. So I'm excited to hear a brief introduction of DataBlocks. Mark, if you could take it away, kind of break away from the block explorers for a second.
Yeah, so we're building a data substrate that would enable for anybody to, so I guess the mission, what we're trying to do is we're trying to build the data layer for the decentralized internet. And ultimately, we actually believe that decentralization is going to do to the internet what electric cars did to, is doing to the car industry. We're seeing, like, electric cars beating gas cars in performance, in security, in terms of like they're the safest cars in the world. The maintenance over time, like the cost of having an electric car in terms of its lifetime. We're also seeing that actually, like Teslas are the very first vehicle that may very likely be an appreciating asset, because with autonomy, you can rent out your car and have them drive around other people, and you can actually generate value. So we see decentralized networks and decentralization as a whole, including the data, very similar to the electrification of cars. Data, so we're building a hyper data transport protocol. Basically, it's an engine. It compiles down to WASM. It's coded in C++. This engine can run in any runtime environment. It can run everywhere. It can run in your phone. It can run in an IoT device. It can run in an autonomous vehicle, run in any kind of sensor. It can run in a data center. It is an engine that allows you to get data in any format you want it to. We don't have a data model. So if you think about like a traditional MongoDB or a Postgres database, you have, like, it's a relational database, or you have a graph database, or you have different, like, key value database that serve different purposes. And typically you have applications that are built with multiple databases, or now we're seeing the era of a multi-model database where you can do multiple models within a single database. This engine doesn't have the notion of a data model. We have the notion of query models. And this idea of a query model plays very well into the sense of decentralization, in that the client or the developer that's building an application using our engine defines a query scope of the queries that the developer wants to have sharded from a data set. So let's say you're running our engine against the Ethereum blockchain. So we have an Ethereum integration that we've built out. You define, I want, transactions, I want block size, block IDs. Like you define the queries that you want. The engine dynamically shards in our case, what we call DataBlocks, to fit the query scope that a developer defines in our SDK. It gives you just the data you need, highly compressed, and it queries on all the data locally at the endpoint, at the edge of the network in the client itself. So the queries are insanely fast. You don't have to download the entire blockchain to get access to this data. In some of our benchmarks that we have right now, we are able to get CryptoKitties, like the entirety of CryptoKitties history and transactions in like 30 megabytes, all in the browser. So you can query over all CryptoKitties, do it in the browser insanely fast and very cost effectively, because we push data to the edge in highly compressed, immutable data blocks. You no longer, regarding a query, you don't have to have an API anymore. You don't have to be hitting a centralized cloud server somewhere where you're always having to do a request and get a response and do a request and get a response. Whoever's hosting that infrastructure sees what your queries are. It's not that in and of itself, the data infrastructure that everybody, I would argue that everyone is building on top of today is operating on this client server model. Someone that's building a network, so MadeSafe it talks about this idea of a serverless internet of data that is everywhere and sharded in the network. The network is the database itself. We're very similar to MadeSafe in that respect, but the way they handle data, the database itself is a key value. It's a decentralized key value store, so it's very limited what you can do with the data in their network. But what's also interesting is that they are limited to only the data that's in their network. Like they can have data that it interacts across different applications, which is super awesome and very interesting, but they don't allow you to integrate with other blockchains. And what we see in terms of, and what Emil sees as well in the future of blockchain, is that we think there will be many internets. There will be many intranets that will all be connected into a much more global public network. There's going to be data. There's going to be immutability in all these blockchains that needs to be searchable. That needs to be, you need to be able to collate that information very easily, and also draw relationships between data across different blockchains, across different networks, whether it's stored in a file system like IPFS, or stored in Ethereum, or stored in EOS, or stored in Polkadot, or wherever it's stored. Maybe it's stored in a MongoDB instance that you have privately hosted. It's data that's anywhere. We need a layer that is able to connect data wherever it is, get it to you in the most efficient and performant way possible, but while also getting you this data in this format, the data needs to be trustful. You need to be able to trust that the data you're getting is provably truthful. It is self-sovereign in the respect of, being able to retain value like cryptocurrencies do. Because every time you're able to copy data in the world, whenever you copy data, it loses value immediately. Data has no value because the second you copy data, it's no longer valuable. It's like printing money. The way we handle data today is just like the way the fiat system works before Bitcoin was created. They're just printing money, printing data. We have data leaks. We have all these problems everywhere. It's like mind-blowingly like ridiculous. It's like, okay, like, what the fuck, guys? Like our data, but this is something we all understand. But we're building an engine that removes the database. Then the internet itself becomes the database. Data is immutable, or it can be mutable, but the data itself retains its value as access controls. It has full traceability, copy protection, yada yada. But we're looking to connect all the blockchains. We're looking to connect all data into a universal substrate using this data engine to build intelligent applications. Most importantly, autonomous. What we mean by intelligent applications are autonomous applications that can draw reference on data across many different places, can draw relationships from data that might be otherwise behind an API somewhere without an actual API. The data is all open. but yet it's private. You have a decentralized ID that's associated with this information. At this point, I'm very much rambling, but what we have today is a data engine. We have a website that's up and running with this. We have an EOS and Ethereum integration, which the next meeting that we have, we'd love to demo it for you guys and show you guys what we're pulling from IDEX, what we're pulling from CryptoKitties, and like how fast we're getting this access. We believe that this is going to make really fast dApps, like dApps that require almost no, like it's a zero infrastructure data layer. You don't have to build any backend infrastructure. Getting the data is insanely fast. The queries are private. You truly own your data even at the data layer, not just at the blockchain level, but even on the infrastructure that's built between the app in terms of the application to the blockchain. You own that data. It's private, decentralized. Right now the data for our engine, it's stored in a CDN. So we're still operating in a pseudo client server model, but the queries, the data blocks are stored in the CDN, but the queries you get runs in the client. We want to work on the peer-to-peer network to make this fully decentralized. But what we have is this engine that is very unique in its approach to sharding data, to the query models, to how fast we get you the data, how efficient it is in terms of cost of infrastructure building. But yeah, so that's just a quick little ramble.
It was a beautiful ramble. I was very entertained, and this sounds like an amazing project. I'm sure these guys have some questions for you because I mean, I have some too, but theirs will be more interesting. Anyone have anything they want to ask?
I have a question. So you said you have CryptoKitties in 30 megabytes. Is that
Yes.
event data only, or?
No, that's full transaction history. That's like every trade. That's like the full history of CryptoKitties we have in about 30 megabytes. Yes. So that's highly compressed. When we pull the data into your browser, we don't uncompress the data at all. We're able to query over this data as it's compressed as well. We can show you guys the demo. We can show you guys the file sizes of like the size of the blocks, the size of like the sets. I can actually, let me see if we still have it here.
I saw a beautiful demo of, I think it was like car data. That you showed. I just couldn't believe how lightning fast it was.
And what's your website? You mentioned your website.
If you go to carstory.com, so this is a traditional like production grade environment where the engine's running that's not blockchain, but it utilizes the notion of data blocks, of these immutable blocks that are highly compressed binary blobs that are, the engine, it shards the data, gets you the subset of the data that you need to satisfy the constraints of your application. You define your location, you define the radius, so we can do geospatial queries. We can also do point-in-time queries. So this can be useful to see like point-in-time instances of the blockchain, geospatial queries with the blockchain. So you can imagine like this opens up very interesting paradigms around like how you can display information and create UIs around this data for decentralized applications. But yeah,
is that your main target audience? dApps that want to make a really lightning fast dApp?
So we're actually going after. So that's part of it. We've identified a very interesting. So this engine can actually bring the enterprise, realistically bring the enterprise into blockchain. We think that's very exciting. Because the engine is a production grade engine, we're not just offering, we wouldn't be offering an enterprise like Facebook, for example, the ability to just use a blockchain because it's a blockchain. You know, that doesn't work. That's like selling an electric car because it's an electric car. It's like, hey, you want to buy an electric car? It's electric. Oh, but it's really shitty. It's really slow. It's really expensive. Like, I mean, good luck actually like owning this thing, but it's electric. You should use it. That's very much a usability problem that we're experiencing. But our engine allows you to use a blockchain and get trustful, immutable data fast and very cost effectively with very little infrastructure, better than the old way you used to do it. So we have an engine that we can demonstrate that this is faster than what they're currently using on their infrastructure. Even in the data center, we're faster than Elasticsearch. We're faster than Solar. We're faster than Lucene at indexing. We're like 10 to 100 times faster, and we're faster across every use case. Even in the data center, and because we utilize data at the edge, we don't have to deal with the latency of the network anymore. We get the data, you do all the queries locally in the client itself, so it's insanely fast in that respect. So we have a opportunity to bring enterprises into decentralized networks and and we know that, and not to be, I mean, not to poop on the party, but like public networks don't have any data, and it's like a terabyte. It's like about it's like a terabyte of data with Ethereum. Then Bitcoin's like a couple of 100 gigabytes. But there's no data in these public networks. All the data is in the enterprises, and that data needs to move to these public networks. We need to move that data to Ethereum, to Bitcoin, to wherever this data can best be utilized, or however they want to best build future applications. So we are using this engine to bring enterprises. We want to bring enterprises to blockchain. We think that this is the opportunity to help use these enterprises to connect these different private networks together using this hyper data protocol, showing them the value of having a siloed database is no longer a competitive advantage. Having a siloed database is, and we're seeing it with Facebook, they're getting scrutiny from all these different governments because they're keeping their data in silos, and then the people that they're selling data to, because they can't track that data, is selling data to somebody else who does an under the cover deal with another person who then does another deal with someone else, and then the data gets in the hands of some dude that leaks it, and they're like, well, we didn't sell the data to that guy. Well, Facebook didn't lie. They didn't. They sold it to this guy who sold it to that guy who sold it to that guy who sold it to that guy, and they had no clue. So we want to bring this opportunity to enterprises as a way to offset compliance costs and liability, to help them like move into the crypto world and move into this new decentralized blockchain internet, because it's in their best interest. And ultimately, using hyperdata, you can build totally new application experiences that transcend what you could do with a traditional Web2 application. The easiest analogy I can draw, and I'm sure many of you guys agree, is because we have autonomous vehicles, because we have these electric cars get enabled autonomy in vehicles. By enabling autonomy in vehicles, the user experience of driving in a car is going to be totally different. You might not need a steering wheel anymore. You might be able to have a desk in your car, and while you're sitting in your own car is driving you somewhere, you could be doing work, and you could be watching a movie, and you're hanging out with your girlfriend or your wife and your kids. So the user experience of a car is going to totally change. The interface of the experience once you get into a car is going to change. And our applications are going to do the same thing with decentralization and autonomous data. It's going to totally change the way applications are built and made, and it's going to be much anyway. Let's stop rambling.
Well, one last question from Mark, if anyone's got it. No?
Cool.
Okay,
We'll
cool.
show you guys demos in the next meeting. We'll show you guys like how this works and what's going on. It's super cool. We'll show you guys demos next meeting.
Yeah, the demos are going to be good. You guys should definitely tune into the next one, because seriously, he blew my mind. Were we in Denver? You were showing me
We're in Denver. Yeah.
Yeah,
But if you guys want to check it out, Car Story. Try Car Story. Set a location. Do the most miles you can. And then as soon as you start interacting with the user experience, you'll notice the number of cars changes instantly in your browser. Like, you'll be interacting with it. We draw intelligent insights on the data through using machine learning. So you'll see we can do machine learning over this data as well. So we could have very personal insights on the data that is being drawn in the client. We can do statistics over the data in the client. This doesn't require having to hit a server every time you need the data. You get the data. It's insanely fast. It's faster than anything that you've used on the internet. It's awesome. It's super awesome. And we're really excited to start bringing this to crypto and like give all of us the tools to like build great applications.
It's a really sexy tool, I gotta say. But let's keep this party going. We got another block explorer here from a chain that I don't think most people even know is around. If they haven't been around for a while, DFINITY has been kind of under wraps lately. Dylan, do you want to give us a heads up on what's going on with the Explorer, and maybe even a little bit about DFINITY itself?
Yeah. Well, this is just a community project, so I don't know that much about DFINITY itself, but their last update, they said they were going to launch maybe in Q3 of this year. We'll see if that happens. You know how software release schedules go.
But what is DFINITY, and what's the story there?
What is DFINITY? DFINITY is like, they're trying to build an internet computer, which is kind of like what Ethereum used to call itself, right? So yeah, DFINITY is building, it's basically like a smart contract platform, I would call it, although they're trying to get away from that term. But you know, it uses a different kind of form of consensus with distributed key generation and like this BLS consensus. And yeah, I'm probably not the best person to give the full breakdown on DFINITY technology. I wasn't prepared for that.
Yeah,
today.
sorry, I put you on the spot there. I mean, I know it's a pretty cool project. They're really deep into neural networks and trying to model with threshold relays, and I think they have an on-chain governance strategy.
Yeah,
that's pretty
they have the on-chain governance, the BNS system that they're gonna use, where like you could set up follow relationships to do your voting, so you don't necessarily have to be an expert. You can set things up so that you follow different people and your vote can be like delegated to them. Yeah. So
yeah,
the
well,
Block Explorer.
Yeah, please. Sorry.
That's okay. Yeah, so yeah, I was thinking about how long I've been in this group, and it's been since June, so that's been 10 months. So that's pretty amazing to see everyone's progress and see the new people who have joined and everything. It's really cool. But DFINITY, like I was talking about, they haven't launched yet. So we're trying to build a block explorer for something that doesn't exist, which is kind of a crazy thing to do. But what we've tried to do is get all the parts in place that we can without the actual network. So what we decided to do was to create like a simulator that's creating blocks and transactions, and they're really simple objects. They just, you know, the blocks just have a list of transactions, a block height. The transactions just have like, you know, amount of tokens that are contained in them and a hash and things like that. But so there's a simulator running in the back end, and we've tried to implement everything we can. So probably the best way for me to explain where we're at is to show you guys. So maybe I could share my screen. Let's see. Okay, can you guys see that?
Yep, looking good.
Okay, so this is like the home page here. Probably if I show you our about page, would be a good way to show you like what the tech stack is. So our front end is React, and then we're communicating with the back end through GraphQL. So we use something called Prisma, which I'm not sure if you guys are familiar with that, but it replaces traditional ORMs. And what it does is provides a GraphQL interface to a database. So in our case, this is a Postgres database. So the way we have things set up is that in the server is generating these blocks and transactions, and it uses GraphQL mutations to write to the Postgres database through Prisma. So it like creates a block object in memory, and then writes that out to the database. You know, the block object contains a bunch of transactions. And then in the front end, it subscribes to get updates through Prisma, through our server, of new blocks and transactions that are written. So you could see here that new blocks are coming in about every 3 seconds, and new transactions are coming in as well. So like this blocks list has a subscription to receive a notification for every new block that is created in the database. And this transactions list is similar. It has a subscription to get notified of every transaction that gets created in the database. And using the Apollo GraphQL client library, they're just able to just update dynamically like that. And then so up here, you can see it's like just like a dashboard kind of design. Here too, this blocks, the block height is kind of coming from this subscription of the new blocks that are coming in. So this block height is dynamically updated. in our server, we're calculating certain statistics like the average block time and the average transaction rate, transactions per second. And we actually store those in the database. So for every block that gets created, we're kind of updating these average times, and then that gets stored in a record in the database. And then here in this dashboard, these are subscribing to those objects. So whenever that object gets updated in the database with the network statistics, these guys get updated here in the front end. Similarly, like with this transaction history graph here, the way that works is that the server writes the number of transactions per day to the database, and so there's like a history of that in the database, and when you load this page, it just goes out to the database through a GraphQL query and just asks for the past 14 days of transaction history, number of transactions per day. For the price information, we're using the Nomics API, and since there is no DFINITY price yet, DFN price, we're just taking ETH and dividing that by a number to kind of get close to what DFINITY futures are trading at right now. So here too, this price card in the UI is subscribing to a price object that's in the database, and whenever that object gets updated, this price will update. I don't know if it's updated here when we've been sitting here. It happens every 10 seconds or so. So if the ETH price isn't changing, this isn't going to really update much. But here too, the price history. This actually doesn't get stored in the database at all, but it's still going through GraphQL to our application server. So when you load the page, there's a GraphQL query that asks the application server for the last 14 days of price history. The application server then goes and makes the Nomics API call, which is like a REST call, gets the data back, puts it into the format for GraphQL, and then sends it back to the front end here. So everything that the front end gets is through GraphQL, through the application server. And yeah, so a lot of what we've done is like, front end stuff, because like I said, DFINITY hasn't launched yet. So there's not that much we can do with the actual data itself, but like there's a light mode and a dark mode. So, this all works with light mode as well, or dark. I have this about page here. It shows our Twitter feed, some information about the project. Also implemented things like search. So, you could search for a transaction here, and it'll show you some details about the transaction. You could search for a block, and it'll show you details about that block. And let's see, is there anything else I was going to show here? I think that's about it. So,
well, cool. Anyone? Well, I'm curious. What are canisters?
Canisters, smart contracts. So that's like the name DFINITY is currently using instead of smart contracts. But the way they want to set things up is that you have this web canister object that could hold both the WebAssembly for the actor, the smart contract, but also your front end code as well. So it could have your JavaScript in there, your React in there, and everything is like packaged into one package. That's the canister. And so then you would, that's like your dApp basically. And you could, all of that could be stored on the DFINITY network. And then you would type in a web address, and it would just load up your web app and load the front end code, and then it would be interfacing with the WebAssembly actor that's running on the network.
Very cool. Anyone else have any questions?
Beautiful interface, dude. Very, very cool.
Oh, thanks.
Well done. It's very nice.
Yeah, I
Thank
love
you.
all the progress you've made over the past few months. You've been tweeting a bit, so we've been able to take a sneak peek at that, of course, once in a while. And I guess we like you very much because you are our very best resource to learn anything about the DFINITY project.
Yeah, if I knew Griff was going to ask me, I would have had something better prepared there than like stammering over.
It's cool, man. Well, let's keep pushing on TrueBlocks. There's another project that we haven't talked to in a long time. I'd love to hear the updates on what's going on.
Yeah, great to see all you guys. Thanks for hanging around to listen to me at the very end here. So I think I'm going to share my screen as well because it's easier for me to explain that way. So I've been working kind of on something a little bit possibly upside down or backwards to what most people are working on. I don't build a blockchain explorer. I build tools that allow me to access the data quicker than access the data directly from a running node, as opposed to extracting the entire database into a separate database and then providing a web-based API. And the reason I do that, number of reasons, mostly because of the size of the data that you have to extract. For me, that precludes any regular users from actually having the data, and they have to ask someone else for the data. And that's why I really love this Avado or the DAppNode project, because what that does, it allows me as an individual to run a blockchain in my house. But if I do that and I can't really get the data off of it, or if I need to do a blockchain explorer that requires 10 terabytes of data, I can't really do that effectively. So I'm trying to leave all of the data on the chain and just make the extraction of the data that I want easier. And it turns out, someone mentioned earlier about negative scraping times or negative that you couldn't finish a block within the block time. And because I'm extracting so little data from the chain at each block, I can actually run my scraper once every 5 minutes and it will catch up to the block pretty easily. And what I do is I just look at every block, every transaction, every trace, all the way down into the deepest detail of the trace, and I keep a list of addresses that appear in that block. And that's the only piece of data that I extract from the block. And I put that into a database. And naively, the first implementation of that took up about 70 gigabytes, but I was able to get that down to about 10 gigabytes. So I can store a list of every appearance of an address anywhere in the Ethereum blockchain. And that turns out there's about 1.3 billion appearances of addresses. And I call them appearances because they're not really, they're sort of transactions, but I'm finding about 40 or 50% of all the appearances of an address happen inside of the data, the input data or the event data, and aren't normally found by blockchain scrapers such as Etherscan, for example. When I search CryptoKitties, I find about 40% more appearances than is reported by Etherscan through their API. And I can store it on a small machine, only taking up about 10 gigabytes. But we even went further than that, and we can take this 10 gigabyte index and we turn it into Bloom filters, which allow us to very quickly identify which parts of the data we have to actually expand. And we can store the Bloom filters in only about 800 megabytes. So for the 7.5 million blocks and the 1.2 billion appearances, we can store that in about 800 megabytes, and we can scan it really quickly. So I'm going to show you an example of that. And all of our data lives under, all of our tools live under this sort of overriding tool called Shifra. And Shifra lets us do various things. Like for example, this is a list of all the addresses that I've already scraped with Shifra. So I'm going to show Shifra list and then the address, and that's every transaction on that address. And we're pulling that from a cached piece of data that takes up a very small amount of space on the hard drive. So Shifra has other tools like listing. So this address this is how much data we're storing that allows us to do this query on that address. That's every transaction that ever happened on that address. And then we can do something like this, export. And that's every piece of JSON data all the way down to the lowest level of the data for that particular address. So you could feed this into like a MongoDB or into any kind of database that you want, or you can even export it as comma separated values into a file, for example. Sorry. That's going into a file, and then you can open that file in Excel or something like that. So this lets us, and if we're running this on like a DApp node, it feels to me like this is what it means to have decentralized data, where you're running the blockchain in your own house, and you're actually able to get details on anything that you want to get details on. So let's say I wanted to do Giveth or something. Well, how about the Ethereum? If I wanted to do the Ethereum tip jar, I want to see what's happening on the Ethereum tip jar. I could go like that. I'd say Shifra export the Ethereum tip jar. And now it's scanning the index using those Bloom filters. So it's going through 1.2 billion records here. And now it has its list of data, and this is the data from the Ethereum tip jar. So that is what we're building, but we're building something a little bit more than that, because it's not enough for me that I, Jay Rush, can collect this data. It's really important to me that we can build a system that almost forces people to share the data, because another issue that I have with blockchain explorers is that they become a centralizing influence. And over time, my fear is that the more people are put in a central role, the less likely they are going to be to share data. So I want to design something that purposefully almost forces people to share data. So through Shifra, we have 4 different modes. One allows you to scrape the data. One allows you to ask for the data from other people that have previously scraped it. One allows you, and then it goes through various layers. And the idea is that at each layer, you're either being more or less helpful to the ecosystem as a whole. So the hero is going to build this index directly from a local node, and he's going to pin it on IPFS and publish the addresses of the pinned data on IPFS. And then other people can download this pinned data from IPFS and then start participating in building and pinning the data. So this actually takes about 20 days to catch up to the chain if you start from scratch. This takes however long it takes to download from IPFS. And then this person would only pin the portion of the index that relates to their smart contract or their set of addresses. So this person is pinning everything, this person is building everything, and this person is pinning his portion of the chain, of the index. And what happens now is you get people here are incentivized to participate because they get full and complete access to their data without any ability of anyone ever holding it back, because they've downloaded the portion of the data that they need. And a person that has very few transactions is going to only download a very small portion of the index, and that is good for him because he won't feel like he's taking on more of a burden than he should. And a person with an address like CryptoKitties, if they wanted to download data, they would have to download a very large portion of the data, and they would share it. So they naturally, the people that use the chain more naturally hold more of the data. And you get this, I think you get this naturally occurring distribution of the data so that no one can actually capture the data, and people don't have to go to a central location to get the data. So that's what I'm building. So I don't know how to turn off screen sharing here. Hold on.
It's okay. Well, does anyone have any questions for TJ?
So I'm upside down and backwards to everybody, and I kind
Very
of
cool though.
Yeah. So I want to try to purposefully build things that that have that quality where people that interact in a tiny way help the community in proportion to the amount that they're putting pain onto the community by creating data. And people like that are creating huge amounts of data they should be carrying the burden, because otherwise what happens is we get in a situation where the people that are carrying the burden of delivering the data to the users are put in a centralizing position so they can take advantage of the users ultimately. And I'm not saying anyone's doing that on purpose. It's just natural human behavior is if you have a centralizing position, giving it up is all but impossible over time. And I think we should purposefully design something that doesn't do that. And that's kind of what I've been working on for 2 years, and it's so hard to figure out how to do that, but that's what I'm working on. So. And by the way, I named this group Decentralized Data Now because I want to decentralize the data now.
It sounds like what we're doing, what you're doing, what we're doing are very complex.
Yeah, it's very similar actually. Yeah,
sounds very similar. But we're also a database as well. So we're indexing the data, we're querying the data, but we're also like the database is a serverless database.
Yeah, it's very interesting.
Where like there is no notion of a database actually, which is what's kind of like what's interesting about it. It's like we don't have a notion of a database because the data is everywhere.
Well, for me, the data is on the chain.
Well, it can be on the chain. It can be on the chain, but we're not just limiting it to the data that's on the chain.
You know, I like the data on the chain because it has a hash on it and it can't be faked. So that's another part is that as we develop these systems, if we're simply extracting data from the chain and we're re-delivering it to people, but we're not providing any kind of way to guarantee that the data that we're providing is exactly identical to the chain data, then why have we put it on the chain to begin with?
Oh yeah, no, of course.
So I don't see that happening as well either.
Oh, you're muted, Mark. You're muted.
Oh, whoops! I was saying we share the same philosophy. No, that's exactly how we view it as well. Because also you can't have like data won't have value. Data doesn't mean anything if it's not tied to it. If it's not on chain, then there's no real purpose for the data to exist in the first place in this new future that we're building to.
Yeah.
Yeah. If it's not on chain, it doesn't.
Yeah. If it's not on chain, it doesn't even exist.
If it's not on chain, it's not really data.
Exactly. Yeah.
I really like your new demo, Jay. It looks really cool, and to see all that JSON data spit out as well. I think there should be a rule for this channel to get more console windows in the demos.
Yeah, what is a user?
Yeah, UIs are overrated.
I don't even know
it's a terminal. It's a terminal, obviously.
I don't know.
Well, this one went a little long, guys, and it's overdue. It should go long, of course, but I do have to call it, unfortunately. Got to try to keep it within an hour. But first, make sure you guys add any links or anything that you want people to see in the YouTube description to the agenda document. And everybody who is watching this video, if you want to see all the links, check the YouTube description that Chris is going to put in. Thank you so much, Chris, for organizing this. And thank you again to Gitcoin Grants for sponsoring this and crowdfunding all of our good work here so that we could be herded appropriately by Chris. Thank you, Chris. And if anyone else wants to get on Gitcoin grants today, like right now, and donate to this or any other awesome grants, it's the last day for this $50,000 matching program that they do based off of quadratic voting. So the more people, the more individual GitHub accounts that actually donate $5 to this Gitcoin grant or any of the other grants up there will get matched huge. Like I'm guessing like $5 equates to somewhere around $100 because not many people have been doing it. So they have a huge impact. So if you're seeing this live and you care about any support in any Gitcoin, any in the open source world that kind of suffers from tragedy commons issues, get your impact out. Be generous and throw some dye at us and other projects. And if you guys want to get on Gitcoin grants, like anybody in the data space, message me. I'm very well connected to the Gitcoin crew, and we can try to get you guys up there because I think all of these projects deserve to be up there. Block explorers are a huge tragedy commons issue that hopefully we can solve with donations and eventually something better. But thank you guys, and we will see you guys in probably 2 weeks.
See you soon. Bye.
Bye.
Thank you.
Thanks.